Okay, first this is a reminder of solving inequalities. These are absolute value inequalities. Please pause the tape and see what you can do with these. Remember that the graph of the solution is going to be on a number line. So your first step is moving everything away from the absolute value symbol. So we would, in a way, be solving if this were 3x minus 11 is greater than or equal to 4. So we just ignore the absolute value and we solve for that. So we are going to add 11 to both sides. That's going to give us 15. 15 divided by 3 is 5. So the absolute value, which, yes, happens to be this, is greater than or equal to 5. We're going to do that step on all of these first. So in this case, we are going to add 6 to both sides. That's going to give us negative 8. But when we divide negative 8 by negative 4, two things happen. First, we change the sign, so this becomes 2, but we also have to change this sign. So we actually get greater than. Okay, on our next step, just because we are moving something that's a negative doesn't mean we change the sign. So we have 14 divided by 7, that is going to give us 2. So the symbol did not have any reason to change. Do not take the absolute value and change all of the signs inside just because it's absolute value. We'll deal with that, but later. So we're going to subtract 3 from both sides. We get 6. Then we have this number, and we are going to multiply by the reciprocal of that number on both sides. That will give us 4. 6 times 2 divided by 3, that's 4. We didn't deal with negative numbers, so no reason to change the sign. So once we have those steps taken care of, our next step, because we have the absolute value by itself, is to split it into 2 parts. And when we split it, the first thing that we do is take the equation, whatever it is, without the absolute value symbol. Then, for the second equation, we are going to change both signs. So we're going to have 3 plus 3u. So one side, the absolute value stays the same. Change the sign, change the sign. Now the next thing we need to think about is or versus and. When my absolute value is greater than a number, my graph is going to be something that is a closed circle with an arrow going down and a closed circle with an arrow going up. So that has to be an or case. In this one, when it is less than, that means I'm going to be between 2 values. So because this is not equal to, it's going to be an open circle, but it's going to be in between 2 values. So let's find out what those values are going to be. In this particular case, I'm going to subtract 3, so I get negative 1 divided by 3. So my u has to be less than negative 1/3. This one, I'm going to subtract 1, so I'm going to get negative 5. Subtract 3, I get negative 5. Divide by 3, so negative 3/5. So u is greater than negative 3/5. So if I'm going to label it here, 3/5, 4, 3, 2, 1/5. So the other one is going to be here, and my graph showing between those 2 numbers. I know it's pretty close together. In this particular problem, I am adding 9 to both sides and then dividing by 2. So this one becomes 7. So u is greater than or equal to 7. 7 here. And here I'm going to add 9 to negative 4. That means to negative 5, I get positive 4. 4 divided by 2. 2 is 2, so this one is a 2. Okay, for for my next two problems. So the negative signs don't change until I have to deal with them, but they do cause some problems. Because this is less than, I'm saying and. Change the sign, change the sign. So in both cases, I am adding 2 to both sides. Here, when I add 2, I get 4. Here, when I add 2, I get 0. But I haven't dealt with a negative in front of the f yet. That negative in front of the f is going to end up giving me to divide by -1. And when I divide by a negative, I have to flip the sign. This sign right here gets flipped. -4. And even though I don't actually change my number here, I still have to flip my sign. So I have 0 and -4. So I am greater than -4. So here's my -4. Open circle greater than. Here's my open circle less than. These are and, so I really need to erase this guy right here. And it is between those two values. On the last one, we simplified it to this point here. So now we need to split it into 2 equations. Since it is greater, it will be or. Change the sign, change the sign. So to solve these, I am adding 5 to both sides. When I add 5 to both sides, I get 9 here, and I get 1 here. Dividing by 5 on both sides. Well, I've got some ugly stuff, but b is greater than or equal to, and b is less than or equal to. So if I want to count that out, I can count out in fifths. So if I have a 0, 1, 2, 3, 4, 5, that's my 1. Let's change this a little bit. Don't do that. So if I want to count this out in fifths, that's perfectly okay. 1 and 2. So 9/5 is going to be here. And that is a closed circle because it is greater than. Closed circle because it's equal to. 1/5 is here, also a closed circle, and arrow the other way. Okay. So in this section, we have already solved using the quadratic equation. What we are just going to do in this section is determine how many solutions, which are also called x-intercepts, an equation will have based on a very specific part of the quadratic equation. That part is called the discriminant. It is the part that is underneath the square root sign. I don't actually take the square root of it. I just grab that b squared minus 4ac, number crunch it, and determine if it is positive, equal to 0, or negative. When it is positive, it has 2 real roots, or 2 x-intercepts. One real root, or 1 x-intercept. And if it has no real roots, it has no x-intercepts. That is the only part of the equation we are doing today. just look at what's underneath the square root sign, simplify that. We're not taking the square root of it, we're just deciding, is it positive, 0, or negative? And that tells us our number of solutions or number of intercepts. This is what a graph's like if we're looking at those 3 possibilities. 2 intercepts, it crosses the axis twice. 1 intercept, it actually bounces off. And no intercepts, never crosses. So all we need to do is determine b squared minus 4ac. Every time we're going to look at b squared minus 4 times a times c. We do have to make sure it's in standard form, and then we plug in number crunch. 8 squared minus 4 times 1 times negative 3. Do be careful about watching out for your signs, because we get 64 minus 12 here, no plus 12. Minus here, those two things become a plus. This is 76. How many solutions? It has 2 solutions. First step is to get it into standard form. If at any point it's not in standard form, it will mess you up when you're trying to figure out what A, B, and C are. So take the time to move things. Then I have B. Remember the parentheses, very important, around the square. If you do not have those, you will get the problem wrong. Okay, this becomes positive 36. Negative times all positives, negative, and this is 36. So our answer is 0. That's not how many solutions it has. It actually has 1 solution. Same thing continues. We are just going to plug things into the discriminant portion, which is the underneath the square root. Do watch out for your signs. We always have a negative 4. This is times a negative times a negative. That ends up being 16 minus 16, which is 0, which tells us how many solutions? 1 real solution. This is not in standard form. If we don't have it in standard form, we will make mistakes. We have to add the 1 to this side of the problem. So we have b squared minus 4 times 6 times 1. This is 4 minus 24, which is negative 20. Which tells me how many solutions? No real solutions. This is asking a different question, but it really isn't. It's the same thing. We are just answering a slightly different way. So we are going to end up with b squared minus 4 times 2 times 9. That gives us 9 minus 72, which is negative 63. So how many solutions does it have? So when it has no real solutions, that's also no x-intercepts. It's just asking the exact same question in a slightly different way. I can have a term missing. I don't see my c here. It's really important that you plug it in though, because when I look at this, stop, go away, move, thank you. b is -1, make sure you put that in parentheses to square it, minus 4 times 1 times 0. You have to plug it in as a 0. You can have B or C as 0. So in this case, I end up with 1 minus 0, not 1 minus 4. So I have 1. It is not the number of solutions or number of intercepts. The intercepts are 2 x-intercepts. Continuing, I have 12 squared minus 4 times 1 times 36. So if I see the term but don't see a number, it's 1. If I don't see the term, it's a 0. This ends up being 144 minus 144. 0 is not my answer. 0 is the discriminant. The discriminant tells me I have 1 x-intercept. Okay, that is what we are doing. So your homework is on Google Classroom. Please make sure that you are checking out and making sure you are doing these problems correctly, and let me know if you're having problems. Have a good day.